Good morning, viewers. This is Kasturi Day. Today, I'm going to discuss the numericals of the laws of motion chapter according to ICSE syllabus class 9. Okay, so for this, let us first let me tell you that you need to ring the notification bell and do subscribe my channel to get the notification as soon as a new video is uploaded. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And also, uh, uh, if you are a new viewer to my channel, please do subscribe my channel and don't forget to meditate before you start your day. So for meditation, let us concentrate for just 1 minute, and then we will start with with the discussion. So for meditation, please concentrate on the point of light. Think that light is a point of energy which is spreading, coming on you, falling on you, and it's spreading all over your body, energizing. Body is energized by that light. Light it up. It has no heaviness. You're becoming light. Your body is becoming light. Your mind is becoming light. Whatever you want to study or do today, the day you are starting, that will be very easily accepted by your body and mind. Peaceful, peaceful soul. Feeling that you're really happy and you are enjoying whatever you are doing. Last of all, successful. When you are thanking God for giving this valuable gift at the beginning of the day. So thank you for continuing this meditation. Let us end here and start with the discussion. Okay. For the discussion, the first numerical we will discuss is the linear momentum of a ball of mass 50 grams is 0.5 kg meter per second, find its velocity. So as per the, as we know that change, that is momentum, linear momentum is equal to mass into velocity. So it's given that momentum is 0.5 kg meter per second and mass that is 50 grams, or you can say 0.05 kgs. Okay. So from the formula, that is P is equal to mv, V can be written as P by M. So 0.5 by 0.05, that is 10 meter per second. That is this velocity is 10 meter per second. Okay. Next is a force of 10 Newton is acting on a body of mass 5 kg. So find the acceleration produced. So for this, it's given that force is 10 Newton and mass is 5 kgs. So we know force is equal to mass into acceleration. So mass is given, force is given, acceleration we need to find out. So from the formula, F is equal to ma, then we need to, A can be equal to F by M, okay, and that is equal to 2 meter per second square. Next is a force of 10 Newton acts on a body of mass 2 kgs for 3 seconds initially at rest. Calculate the velocity acquired by the body and the change in momentum of the body. So given F is equal to 10 Newton, M is equal to 2 kgs, T is equal to 3 seconds, U is equal to 0 meter per second as at rest, and let V is equal to final velocity from Newton's second law. See, so what are the things given? F is equal to 10 Newton, mass is equal to 2 kgs, T is equal to 3 seconds. As it is, the body is starting from rest, so initial velocity is 0 meter per second. Okay, and we need to find out now the final velocity. First part of the question is find the velocity which is acquired by the body. So final velocity we need to find out. So from Newton's second law, we know that force is equal to mass into acceleration. So acceleration we can find out from the see this force is given and mass is given. So acceleration will be equal to 10 by 2, that's 5 meter per second square. Now from the first equation of motion, that is V minus U is equal to AT, or you can say V is equal to U plus AT. So from there we can find out A, okay. We can find out the V, okay. So from that V, as we know, we need to find out U. We know it's a 0. A is it is 5 meter per second square. We proved it, and 3 is the time. 3 seconds is the time. So from this we put the formula, we put the numbers in the formula, and we get 15 meter per second is the final velocity. It's the velocity which is acquired by the moving body. Next, we need to find out the change in momentum. So change in momentum is final momentum minus initial momentum, and momentum, we know the formula is m into velocity. So first, final momentum is mass into final velocity, and initial velocity is mass into initial velocity. So if we take mass as common, then it will be final velocity minus initial velocity. M is equal to final minus initial velocity. Sorry, F into final minus initial velocity. That is 2 into 15 minus 0. That is 2 into 15. That is 30 kg meter per second. Change in momentum is 30 kg meter per second. Next is a force acts for 10 seconds on a stationary body of mass 100 kgs, after which the force ceases to act. So it's a force which is acting for 10 seconds. On a stationary body, force is acting for 10 seconds. Time is 10 seconds. Mass, what is the mass of the stationary body? It is 100 kgs. After which the force ceases to act. Force stops. Okay. Then the body moves for a distance. Body is moving for a distance of 100 meters in the next 5 seconds. Next 5 seconds, it is moving for 100 meters. Now, calculate the velocity acquired by the body. What is the velocity which is acquired by the body? The acceleration produced by the force and the magnitude of the force. Okay. So first part, as the body is stationary, therefore, the initial velocity is equal to 0. Mass is given, that is 100 kgs. Time is given 5 seconds. Okay. Next, so distance covered is 100 meters. So velocity of the body will be distance by time. Okay, so distance is 100 meters and time is 5 seconds. So that will be equal to 20 meters per second. First part. Second is the acceleration produced by the force. Now, we know the final velocity, we know the initial velocity, we know the distance covered. So we need to find out the acceleration. So we use here the formula is v square is equal to u square plus 2as. Okay? S is the distance covered. So final velocity as it is 20. So 20 square is equal to 0 square plus 2 into a into 100. Okay? Putting the numbers in place of the formula. Then substituting with the numbers. So we get 400 is equal to 208. So acceleration will be 400 by 200, that is equal to 2 meter per second square. Now we have come to know the acceleration. We know the mass. Okay, so we can find out the force. So force is mass into acceleration. Therefore, mass is equal to 100 and acceleration is 2. That is equal to 200 Newton. Clear? Next is the following figure shows the velocity time graph of a particle of mass 100 grams moving in a straight line. Calculate the force acting on the particle. So for this, see, this is the figure. This is the image. It is the diagram. So velocity is on the y-axis and time is on the x-axis. Okay. So velocity is in meter per second. Time is in only in seconds. So we see when it is covering 5 seconds, within 5 seconds, it has a velocity of 20 meter per second. Okay. So in this way, it is moving. So from the graph, it is seen that the change in velocity, that is delta v, that is equal to 220 meter per second. And for this, the change in time is 5 seconds. So acceleration, we know, change in velocity by change in time. That is 20 by 5, that is 4 meter per second square. Now, as the mass of the particle is 100 grams, the mass of the particle is 100 grams. So as the mass is 100 grams, that means if it is converted to kg, because this is in SI system, which is meter per second is SI system. So this should also be in SI system or in gas system. Okay. So mass should also be in the same system. So that is converted into kg. So 0.1 kg. So force is equal to mass into acceleration. So mass as it is 0.1 into 4. That is equal to 0.4 Newton will be the force applied on the particle. Now, a force causes an acceleration of 10 meter per second square in a body of mass 500 grams. A force is causing an acceleration on a body which is having a mass of 500 grams, and acceleration is given to it. Force is given to it, which is producing an acceleration of 10 meter per second square. Okay, so by the same force, okay, what acceleration will be caused by the same force in a body of mass 5 kgs? If the body has the same force, experiences the same force, what acceleration will be produced if the mass becomes 5 kgs? The first mass was original mass of the body was 500 grams. But if the mass is converted to 5 kgs, then what will be the acceleration produced? So first case, acceleration is given, it is 10 meter per second square. And mass it is given as 500 grams, or you can convert it into kgs, that is 0.5 kgs. So force is 5 Newton. 0.5 into 10, that is mass into acceleration, that is 5 Newton. Now, if the mass becomes 5 kg, then what happens? How much acceleration? Force is remaining the same because the same force is applied on the body of the 5 kgs. So, force is 5 Newton and mass is 5 kg. So, acceleration will be 1 meter per second. So, 1 meter per second square, the acceleration will be reduced if the mass is increased to 5. Now, a cricket ball of mass 150 grams is moving at a speed of 25 meter per second is brought to rest by a player in 0.03 seconds. Find the average force applied by the player. Given mass is equal to 150 grams, or you can say 150 by 1000 or 0.15 kgs. The force, it is rate of change of momentum. We know. Then change in momentum means final momentum minus initial momentum, that is mv minus mu. Okay, and rate of change of momentum is mv minus mu by t. Okay, and that is equal to force. Now, initial velocity, we know it's 25 meter per second. But when it is come to rest, then what happens? The final velocity becomes 0. Okay. Mass, we know it's 150 grams. That means 0.15 kgs. And the time taken by the player, that is 0.03 seconds. Okay. So that will be change in momentum will be mv minus mu. That means mv is 0.15 into 0 and mu is 0.15 into 25. That will be equal to 0 minus 3.75. That means it will be equal to minus 3.75. Okay. So rate of change of momentum will be minus 3.75 into divided by time, that is 0.03. That is equal to minus 125. So rate of change of momentum is equal to minus 125, or you can say force is equal to minus 155 Newton. Okay. So the average force that is applied by the player, that is negative force. Okay, that means what? It is coming to rest. Okay, acceleration will be decelerating. That means it is coming to stop. Okay. Retardation is happening. That's why it is negative. Force is becoming negative. Reducing force, that means it is force is reduced. That's why it is minus. Clear? Now, a force acts on 0.13 0.1 seconds for 0.1 seconds on a body of mass 2 kgs. Okay? So force, the time given is 0.1 seconds and mass of the body is 2 kgs. Initially at rest, that means initial velocity is 0 meter per second. The force is then withdrawn. Force is withdrawn. No force is applied anymore after 0.1 seconds. Okay? And the body moves with a velocity of 2 meter per second. After the force is withdrawn, the velocity starts moving with a velocity of 2 meter per second. Find the magnitude of force. So what happens? Time we know it's given as 0.1 second. Mass is 2 kgs. Initial velocity as it was in rest, so 0.0 meter per second. And after the force has been stopped, the body starts moving and it is having a velocity of 2 meter per second. Okay? So change in momentum will be mv minus mu by t, rate of change of momentum. So that means mv minus u by t, that is mass as 2. So 2 minus u by 2 into 2 minus 0 divided by 0.1. That is 2 into 2 by 0.1. That is 4. Rather, it is 40 Newton. Okay, 40 Newton. 4 by 0.1, that is 40 Newton. The force which is applied, that is 40 Newton force was applied to it to move the body to with a velocity of 2 meter per second. Okay. Next is a body of mass 500 grams initially at rest is acted upon by a force which causes it to move at a distance of 4 meter in 2 seconds. Calculate the force of that. So a body of mass 500 grams. Okay, mass is given as 500 grams, so you can say 0.5 kgs. Initially at rest, that means initial velocity is 0 meter per second, acted upon by a force which causes a body to move a distance of 4 meters. So distance moved is 4 meters and time is 2 seconds. Now what is the force applied? Now from this we need to find out the acceleration first. So distance we know is 4. So that is, we use the formula S is equal to ut plus half at squared. Okay. Now here S is given as 4 meters. So initial velocity is 0. So 0 into 2, that is 2 seconds is required. Time is 2 seconds. So half into A into 2 square plus half into A into 2 square. So we get what? We get acceleration as 2 meter per second square. Now, putting this acceleration, this value of acceleration into the formula, F is equal to mass into acceleration. So mass we know it is 0.5 kgs into acceleration, that is 2. We get the force as 1 Newton. Next, a car of mass 480 kgs moving at a speed of 54 kilometer per hour is stopped by applying brakes in 10 seconds. Calculate the force applied by the brakes. Given mass is 480 kgs, speed is 54 kilometer per hour. It is moving with a speed of 54 kilometer per hour, or you can say 15 meter per second. We convert it to kilometer per hour to meter per second by multiplying with 5 by 18. Okay, so that is 15 meter per second. And as it is coming after the brakes applied, it comes to rest. So when brakes is applied, the speed reduces to 0. So that means final velocity becomes 0 meter per second. It is stopped. So calculate the force. So time is 10 seconds. So from this we can find out the acceleration, that is v minus u by t, that is 15 minus 0 by 10. Okay. So that is 1.5 meter per second. So we know the mass, that is 480 kgs. We know the acceleration now. So we can find out the force. Force is equal to mass into acceleration. So we put the values and we will get 720 newtons. Then a car is moving with a uniform velocity of 30 meter per second. If it is stopped in 2 seconds by applying a force of 1500 newton through its brakes, calculate the change in momentum of the car the retardation that is produced in the car and the mass of the car. So initial velocity, it is moving with an initial velocity of 30 meter per second. So given initial velocity is 30 meter per second, as it is coming to rest, it is stopped, that is, it is coming to rest. So final velocity becomes 0 meter per second. Okay, time taken is 2 seconds. After 2 seconds, it is stopped. So 2 seconds timing, force which is given is 1500 Newton. So from this, we can find out the acceleration first. Acceleration is equal to v minus u by t. So final velocity is 0, 0 minus 30 by 2, that is minus 15 meter per second square. Okay. Now from this, as it is a negative value, that means it is retardation. That's why acceleration is negative. Okay. So retardation is 15 meter per second square. Now, from this, we can find out the force. Force is given. So from this, force is equal to mass into acceleration. So we can find out the mass. So mass is force by acceleration, that is 1500 by 15, that is 100 kgs. Now change in momentum is mass into final velocity minus mass into initial velocity. So first we know the mass. So mass is 100 into 0 minus 30, that is 100 into 30. Okay, so that is minus 3000 kg meter per second. Why it is minus? The negative sign indicates that there is a decrease in momentum. Momentum is gradually decreasing because it is retardation is there. So that's why the momentum is decreasing. So this is shown by the negative sign. Now a bullet of mass 50 grams moving at an initial velocity of 100 meter per second strikes a wooden block and comes to rest after penetrating a distance of 2 centimeter in it. Calculate initial momentum of the bullet, final momentum of the bullet, retardation caused by the wooden block, and resistive force which is exerted by the wooden block. So a bullet of 50 kilograms, mass is 50 grams, that is given. Mass is 50 grams, that is 0.05 kgs. Initial velocity, it's moving with 100 meter per second. So initial velocity is 100 meter per second, 100 meter per second. After penetrating, it comes to rest. So that's why it is 0 meter per second. Final velocity. Then distance covered is 2 centimeters, that is 2 by 100, that is equal to 0.02 meters. Okay. So this initial velocity, initial momentum is m into initial velocity, that is 0.05 into 100, that is 5 kg meter per second. Final momentum is mass into velocity again. Here final velocity is 0, therefore that is 0 kg per kg meter per second. Now for retardation of the bullet, that means negative acceleration. So final velocity, that is the formula we use here, it is v square is equal to u square plus 2as. Okay. So final velocity is 0 square, initial velocity is 100 square plus 2 into a into distance covered is 0.02. Okay, so that means acceleration will be equal to how much? Minus 2.5 into 10 to the power 5 meter per second. So the negative value indicates that it is a retardation. Okay. Now the resistive force, how much force was applied to stop this car? Okay. So F is equal to MA, that means 0.05 into 2.5 into 10 to the power 5, that is equal to minus 12,500 Newton. Again, why it is minus? Because it is a resistive force. It is stopping the car. Then a force pushes a wall with a force of 10 Newton towards east. What force is exerted by the wall on the body? Sorry, on the boy. So the boy experiences an equal force because that much force he is giving, the equal and opposite force will be coming on him also. So that means 10 Newton force is putting on the wall. So that much force will also be coming on him in the opposite direction. That is in the west. Okay. In the following diagram, a block of weight 15 Newton is hanging from a rigid support by a string. What force is exerted by? The block on the string on the block, name them and show them in the diagram. So a block which is 15 exerts which 15 kg force. Okay. 15 Newton, sorry, 15 Newton force weight on the string downwards. So 15 Newton force will be acting downwards from the, that is the weight of the body, which is pulling it downwards, okay? And the string which is pulling it up. So that is 15 Newton. Again, the same amount of force will be applied in the opposite direction, that is in the upward direction. So this diagram will be like this. Tension will be upwards and downward will be the weight. The force of attraction between the two bodies at a certain separation is 10 Newton. What will be the force of attraction between them if the separation is reduced to half? So given the force of attraction between the two bodies is 10 Newton. And as per the formula, we know that F is equal to G into M by R squared. Okay. So if the new distance R dash, okay, it is equal to R by 2. That is R dash is equal to R by 2. Here it is seen that is reduced, the radius is reduced to half. That's why the R dash is the new distance and that is equal to the radius which has been halved. The original radius is being halved. So then F is equal to F dash, same force is applied. So that means F dash is equal to capital G M into M by R by 2. In place of R dash, we write R by 2 whole square. Okay. So that means G is equal to M into M by R square by 4. That is equal to 4G M into M by R square. Or you can say the first was F is equal to G M into M, capital M to M by R square. That means this one, in place of this formula, G M into M by R square, G into M into M by R square. In place of this, we can write the capital F. So F dash is equal to 4F. Or you can say F as F is equal to 10 Newton. So F dash will be equal to 4 into 10. That is 40 Newton force. Now write the approximate weight of the body of mass 5 kgs. What assumption have you made? Now given mass, we know it's 5 kgs and weight is, we know that mass into acceleration due to gravity. And G, if we consider it as 10 meter per second square, 10 meter per second square, 9.8, we can approximately round off it to 10 meter per second square. So then we get that W is equal to 5 into 10, that is 50 Newton. Weight is 50 Newton. So assumption is G is equal to 10 meter per second square. Now state the magnitude and direction of the force, okay, of the gravity acting of a body of mass 5 kgs. Take G is equal to 9 meter per second. Here it's very simple. Mass is equal to 5 kgs and G is equal to 9.8 meter per second. So force is equal to mass into gravity. That is F5 into 9.8 is 49 Newton, which is acting vertically downwards. Okay, direction of the force is vertically downwards. Then because it is acceleration due to gravity, so gravity will be pulling it down. The weight of the body on Earth is 98 Newton. Okay? Where the acceleration due to gravity is 9.8 meter per second. What will be its weight, mass of the moon? Sorry, mass and weight on the moon when the acceleration due to gravity becomes 1.6 meter per second square. So weight we know it's 9.98 Newton, gravity is 9.8 mass meter per second square. So mass will be what? W is equal to mg. Okay. So sorry, weight will be sorry, I'm very much sorry. It is W is equal to m into g. So mass will be W by g. That is 98 by 9.8. That is equal to 10 kgs. Now we know the mass. The mass is constant everywhere. Weight only differs due to the gravitational force. Now on the moon, we see the gravity becomes 1.6. So here the weight will become mass into gravity, that is 16 Newton. Clear? Now a man weighs 600 Newton on the earth. What will be his approximate weight on the moon? Give reason for your answer. So weight on the earth it is 600 Newton, and we know weight on the moon is 1/6 that 1/6 of the weight on the earth. That means 600 Newton if it is on the earth, so 1/6 will be 1/6 of 600 will be on the moon. Okay, so gravity will also be 1/6 that of the earth. Gravity on the moon will also become 1/6. Okay. So weight of the moon, weight on the moon will be equal to 1/6 of the 600, that is 100 Newton. Okay. Okay, as gravity on the moon becomes 1/6 of the that of the Earth, which is on the Earth what it is, it becomes 1/6 on the moon. That's why weight also becomes 1/6, because that means 1/6 into 600, that is 100 Newton. Then what is the force of gravity and weight of the block of mass 10.5 kgs, g is equal to 10 meter per second. Mass it is given 10.5 kgs and gravity is 10 meter per second square. So force we know, mass into gravitational acceleration due to gravity. So 10.5 into 10, that is 105 Newton. Okay. Now weight. Weight is m into g. Again same thing. And mass into gravity, that is again 1.105 Newton. Now a ball is released from a height and it reaches to the ground in 3 seconds. If gravity is 9.8 meter per second, find the height from which the ball was released and the velocity with which the ball will strike the ground. So given t is equal to 3 seconds and g is equal to 9.8 meter per second, and it is falling from the top, so it is starting from the velocity 0 meter per second. Maximum height, that is, it is falling from the maximum height, so that there the velocity becomes 0. So it's starting from there, so that is 0 meter per second. Okay. Now s is the height from where the ball is being released. So s is equal to, we use the formula here, it is s is equal to ut plus half gt square. That is equal to 0 into 3, that is substituting the formula with the numbers, so values rather. So we get 44.1 meters. Now, if v is the final velocity and with which the ball strikes the ground, then we see v square is equal to u square plus 2gs. So v square is equal to u square plus 2 into 9.8 into 44.1. So v square will be equal to 29.4 meter per second. Next is, what force in Newton your muscles need to apply to hold a mass of 5 kgs in your hand? State assumption. The given mass is 5 kgs and it is assumed that g is equal to 9.8 Newton per kg. So we see that F is equal to mg. Okay, or you can say 9.8 meter per second square, as it is acceleration due to gravity. So therefore we get 49 Newton mass into acceleration. So assumption is g is equal to 9.8 meter per second square, or you can say g is equal to 9.8 Newton per kg. Now a ball is thrown vertically upwards. Okay, it goes to a height of 20 meters and then returns to the ground. The acceleration due to gravity is taken to be 10 meters per second square. So initial velocity of the ball, final velocity of the ball in reaching the ground, and the total time of the journey of the ball. Now the ball travels upwards when it travels, so that is 20 meters. G, we know it's 10 meters per second square. Okay, when the ball is thrown to upwards, and when it reaches the maximum height, so there the velocity, final velocity becomes 0. From there, it starts dropping. So from there, when it starts dropping, its initial velocity is 0. Okay. So we use the formula. When it is reaching the maximum height, its final velocity is 0. Okay, so when it is reaching the maximum height, its final velocity becomes 0. So when it is thrown upwards to the maximum height, it is final velocity is 0. So it is v square is equal to u square plus 2gs. Sorry, minus 2gs, because it is moving upwards and opposite to the gravitational force. So u square will be equal to 20 meters per second. Using the formula, v square is equal to u square minus 2gs. Now, as the ball reaches the ground, when it is coming down, the ball is moving towards the ground. Okay, so that time, what happens? When it reaches the maximum height, I told you the final velocity is becoming 0. From there, it is coming down. So when the final velocity is becomes 0, so when it is starting from there, its initial velocity becomes 0. Now, what happens when this initial velocity becomes 0? So it will be, the formula will be v square is equal to u square plus 2gs, because it is coming down towards the ground, towards the acceleration due to gravity, towards the gravitational field. So that time, here also the final velocity becomes 20 meters per second. Okay. Now, for the total time, that is going up and again coming down. Okay. So the first T1, when it is going up, v is equal to u minus gt. That time its final velocity was 0, initial velocity is 20, g was 10, t1 we don't know. So that time t1 becomes 2 seconds. Okay. Now when it is starting from its maximum height, that time v is equal to u plus gt. That time also we see it's 2 seconds. So the total time will be 2 plus 2. That is 2 plus 2, 4. 4 seconds total time. Okay. Now a body is dropped from the top of a tower. It acquires a velocity of 20 meters per second. On reaching the ground, calculate the height of the tower. Take g is equal to 10 meters per second. So when the body is dropped from the top of the tower, that is from the maximum height. So from there, the initial velocity will be 0. Okay. The final velocity is given as it requires a velocity of 20 meters per second. So final velocity will be 20 meters per second, and g, that is given as 10 meters per second square. The height of the tower, let's say it is h. Okay. Now from the formula, v square is equal to u square plus 2gh, because it's coming back towards the ground. So that will be, if we put the formula, we say the numbers, values of the formula, then we will get that h is equal to 20 meters. Okay. Next is, a ball is thrown vertically upwards. In return, 6 seconds later. It is thrown upwards, it returns back after 6 seconds. Now calculate the greatest height reached by the ball, the initial velocity of the ball, taking g is equal to 10 meters per second. So total time is 6 seconds, going up and coming down. Time taken to reach the maximum height is total time by this one, half, that is 2, that is 3 seconds. Okay. Now when it is reaching the maximum height, the velocity, final velocity becomes 0. Initial velocity is u, starting with u, but when it reaches the stop, it is final velocity is 0. Given g is equal to 10 meters per second. So when it is going upwards, v is equal to u minus gt, then u will be 30 meters per second. Now initial velocity is 30 meters per second. Now to calculate the maximum height, when it is going up, final velocity is 0. Initial is 30 meters per 30 meters per second, so 30 square minus 2gh, that is 28. So h is equal to 45 meters. Now, a pebble is thrown vertically upwards with a speed of 20 meters per second. How high will it be? After 2 seconds? G is equal to 10 meters per second. Again, u starting with 20 meters per second. When it is reaching the maximum height, velocity becomes 0. Final velocity becomes 0. 2 seconds it reaches to go up. Okay. And g is 10 meters per second square. So s is equal to maximum height we need to calculate. So s is equal to ut minus half gt square, because it is moving against the gravity. So it will be 20 meters. Okay. Now how long will a stone take to fall to a ground from the top of a building 80 meters high? And another is, what will be the velocity of the stone on reaching the ground? As the stone was dropped from a height, so its initial velocity was 0. Free fall it is, so it's 0. Initial velocity is 0. And height is 80 meters, it's given. Okay, g is also given as 10 meters per second. So formula ut plus half gt square, because it is coming towards the gravity. So it will be t will be time to, okay. So time will be 4 seconds at least. Okay, so final velocity will be v is equal to u plus gt. So that will be equal to 40 meters per second. Now a body falls from the top of a building and reaches the ground in 2.5 seconds later. How high is the building? V is equal to 9.8 meters per second. Okay. As it is falling from the height, it will be a free fall, so the initial velocity will be 0. So g is equal to 9.8 meter per second square, and t is 2.5 seconds. So it will be formula we use here is S equal to plus half ct square. So that will be equal to 30.625 meters. Next, a ball is thrown vertically upwards with an initial velocity of 40 meters per second. 49 meters per second. Calculate the maximum height attained, the time taken by it before it reaches the ground again. So initial velocity when it is thrown from ground, it is 49 meters per second, but when it reaches the maximum height, it will be 0 meters per second. Okay. Now from the formula, v square is equal to u square minus 2gs or 2gh. It will be s is equal to 122.5 meters. Okay. Now, second part, we need to find out the time taken before it reaches the ground. So that will be, it is before it reaches the ground again. Okay. So it is moving up. Okay. Yes, we need to find out the time before it reaches the ground. So when it moves up, it will be using the formula v is equal to u minus gt. Okay, because it is moving against the ground, the time will be 5 seconds. And as the time of ascent is equal to time of the descent, same timing it's taking. Okay, so that will be same as it is coming down. Okay, so therefore it will be 5 plus 5, that will be 10 seconds. Now a stone is dropped freely from the top of a tower and reaches the ground in 4 seconds. Take g is equal to this one, calculate the height, 10 meters per second. So as the stone is dropped from the height, so its initial velocity becomes 0 meter per second. It's a free fall. No? So given its time is 4 seconds, u is 0 meter per second, and g is 10 meter per second. So formula s is equal to ut plus half t square, that will be equal to 80 meters. Next is, a pebble is dropped freely in a well from its top. It takes 20 seconds for the pebble to reach the water surface. Okay. So from the top of the well, it is dropped. To reach the surface of the water, it takes 20 seconds. G is equal to 10 meters per second, and the speed of the sound is 330 meters per second. That is we need to find the depth of the water surface and the time when the echo is heard after the pebble is dropped. Okay. So given T is equal to 20 seconds and G is equal to 10 meters per second square. As the pebble is dropped from the top of the well, its initial velocity is 0 meter per second square. It's 0 meter per second. So the as it is moving towards the ground, so it is s is equal to ut plus half ct square. So it will be 2,000 meters. From the top to the surface of the water is 2,000 meters. Okay. Then the time taken when the echo is heard is, speed of the sound is 330 meters per second. Okay. Depth is 2,000 meters. It's all there. Okay. So speed will be distance by time. Okay. So time will be distance by speed. That will be equal to 6.1 seconds. Now, as the pebble takes 20 seconds to reach the water surface, the total time when the echo is heard is 20 plus 6.1, because it will come back to the listener. No? Okay. So that will be equal to 26.1. A ball is thrown vertically upwards from the top of the tower. Okay, with an initial velocity of 19.6 meters per second. The ball reaches the ground after 5 seconds. Calculate the height of the tower, the velocity of the ball in reaching the ground, and take g is equal to 9.8 meters per second. So see, this is the tower, initial tower from the ground. Its height is h meters, and here the initial velocity from the top of the tower, the stone is the ball is thrown upwards. So from the top of the tower, its initial velocity is 19.6 meters per second. And when it is reaching the maximum height, that velocity becoming 0 meters per second. Now from there, the ball is coming down to the ground. So from the top of the tower to the maximum height, it is x. Say it is x meters. So the total height the body is covering is x plus h. So height, the total height is, the wall is covering is h plus x. So u is equal to 19.6 meter per second and b is equal to 0 meter per second. Total time is 5 seconds and g is equal to 9.8 meter per second. So from the equation b is equal to u minus gt, that means equal to time will be equal to 2 seconds. Okay, this is the time for the ball to go up from the top of the tower to the top. Now, time taken to come down. Total is 5 seconds. So, total time it's taking 5 seconds. No? So, 5 minus 2, that means 3 seconds to come down. So, height of the ball above the tower is, height reached by the ball above the tower is v square is equal to u square minus 2g x, x above the tower. So, that will be equal to 19.6 meters. Now, total height from the ground will be h is equal to ut plus half gt square from the ground to the total height, that is capital H, that is h plus x. Okay. So, that will be equal to 44.1 meters. Okay. Now, that means total height of the building will be, total height is h plus x is 44.1. and only x is 19.6. So the height of the tower will be 24.5 meters. See, from the diagram you can see this total height is 44.1. This total height, this one, h plus x is 44.1, and this much from the top of the tower to v, that is 19.6. So this h will be equal to 44.1 minus 19.6, that is 24.5. Now, for the velocity of the ball on reaching the ground, that will be equal to v plus u plus gt. V is equal to u plus gt, that will be equal to 9.8. Because u is equal to 0. That will be equal to how much? 29.4 meter per second. So, this much for today. Like the next video, I will start with the biology chapter. So till then, please go through this. If you have any doubt, please do write in the comment box. Do share with your friends. And if you are liking the videos, press the like button, share with your friends. Okay. And if you are a new subscriber to my channel, please do subscribe and ring the notification bell, because that will notify you as soon as a new video is uploaded. So thank you. Thank you for watching and have a good day.